Hello everyone. Uh, I just want to caution you that whenever you are following a particular video, right now, this is, I think, in Kinematics, it is my seventh video. And if you really want to follow, I would advise you to follow all my previous videos, right from Kinematics 1 onwards. And then one more thing that I want to tell any of these viewers, you may probably give your comment about the video. And if you have any queries or questions, you can put it in your comment section so that I'll try to clarify in my subsequent videos at any point of time. I'll give a heading for that, queries of the previous videos, etc. Likewise, okay? Now, let us get back to the point where I left off in my previous video. There I was talking about graphs. First we saw position time graph, various possibilities we saw, and displacement time graph, distance time graph we saw in the previous case. Now we have shifted our attention to velocity time graph. I think I have given you a few cases. If I drop the body, how does it look like? And if it is a projected body reaching the same level of projection, how does it look like? I have given one very important point in velocity time graph. In fact, for your information, always remember, whenever a graph is given, there are two things that you should always be careful about. Number one, the slope. Is its slope, is it zero? Is the slope positive? Is the slope negative? Is the slope variable? First, these are the 3-4 points that you have to see in slope. The second most may not be in all graphs, but in most of the graphs, area under the curve, here of course it is a straight line, area under the straight line with the time axis is what I am giving. With the time axis, what does that give you? You remember, in a graph, slope we can get by derivative, or derivative is represented as slope, instantaneous slope. And integration is nothing but area under the curve with the appropriate limits. Now, when you take, I have written down clearly here, the area under the curve with time axis gives displacement, in which case velocity time graph, right? Provided you consider its appropriate sign. What do you mean by appropriate sign? Now look at this case. I have already drawn a case here. Above this, which is positive, I have put those horizontal lines, and below this it is negative. I put those vertical lines here. Now this area is positive, this area is negative, right? Now you sum up the total area. Incidentally, this body projected to this point comes back to the same point. Obviously, displacement is zero during time of flight. So this positive area, negative area are one and the same. The sum is equal to zero. I hope you got this point. Now this is when you take the appropriate sign. Supposing we ignore this sign, then you will get distance. This is important. So this is 10 units, this is 10 units, total is 20 units. If you want to get the displacement plus 10 and minus 10, it is equal to 0 in this case, not necessarily in all the cases. I hope this is clear to you. Now this is a very important point. Area under the curve in a velocity time graph always gives displacement if taken with appropriate sign, and distance if taken with by ignoring the sign. Okay. Now let me tell you how to represent a body projected from the top of a tower. Let me presume is an example that I have already shown you in my previous case as well. Now I want you to plot the velocity time graph. Now, this is how it starts off. That's how it goes. Now, what is this positive area? You can see What is the negative area? All this. Now very clearly you can see the negative area is more than the positive area. But during the time of flight, the displacement is minus h. Now you can see positive area is less, negative area is more. Now remember, this area has to be obtained with the help of any geometry. Generally problems are given where you can get either a circular in shape so that the area is easy to calculate. Otherwise, you can use your geometry of, in general, you come across either squares or triangles, etc. Now you can see that this whole negative, maybe this is around minus 30, this is plus 10, therefore the displacement is minus 10, and that is magnitude of this displacement is nothing but the height of the tower. That is the height of the tower. You have to understand that. That is number one. Number two, if I want to get the distance, maybe this is 30 units, this is 10, it is 40 units. Now 10 units and this is 30 units. Now that's how you are going to get the velocity time graph when you project a body from the top of a tower. Now, if I go to our bouncing ball problem, the bouncing ball problem I already told you. Say for example, I am projecting it up. It goes up, comes down. Now how to draw? This is an ideal case.